My name is Fahad Ali Shah and I am a student of Ikra University. My ID is 43484. Today we have learning about input and output. Understanding of input output techniques, programming, interrupt, driving IO, DMA configuration, IO channel firewalls. In this uh, lecture, we have described a wide variety of parahepticals deriving different amount of data at different speeds and different formats, all slower than CPU and RAM. Need IO modules. Interface to CPU and memory, interface to one or more peripherals. Address lines, these are address lines. We have three address lines. The number one is address line, number two is data lines, number three is control lines. And this is the IO module, inter-operating module, system bus linked to peripheral device. These four devices we can connect it in this IO module, and these three layer, these three paths, that address line, data lines, and control line. And however, you can see that the address line is a path that direct connected to the IO model, and data line is a path which directly connected in IO model and then go to the system bus, and then control line is a path which can connect it in IO model and then go to the system bus. Next we have readable screen, printer and keyboard, machine readable, monitoring and control and communication, modem, network interface and card. So that's called an IC, network interface card. Then CPU check IO module device status, IO module return status. If ready, CPU request data transfer. IO module get data from device, IO module transfer data to CPU, variation for output, DMA, etc. Then we have a diagram that you can see in your screen. Interface to system bus and data lines, data registration, status control registration, IO logic, external device interface logic, external device interface logic. So we have both external device interface logic that you have seen in the screen, and my right hand, and there is the IO logic. We can connect data status control that both devices interface to external device. And there's a IO module diagram which can address line, data line and control line in IO logic. And data line is connected two parts, data registration and status control registration. And then externally device interface logic and external device interface logic, this both are connected IO logical. So here there is a IO module diagram. Next one, we have program interrupt driven direct memory SSDMA. Input output techniques, and three techniques for input of a block of data. Issue a read command to IO module, CPU IO, and there is a very large amount of you can next instruction program IO and next instruction B, and then is this C directed memory access. Issue a read command to IO module, read status of IO module and check status, then read word from IO module, write word into memory, and then done. So we can connect it 1, 2, 3, 4 and 5 path, that CPU IO, CPU error condition, and then CPU and CPU memory. And then in my right hand in the middle, issue read command to IO module, read status of IO module and check status, ready, read word from IO module, write word into memory, and then done. So issue read block command to IO module and read status of DMA modules. That's the very readable diagram, three techniques for input of a block of data. Next one is a CPU is a direct control over IO sensing status, read write command, transferring data. CPU waits for IO module to complete operation with CPU time. The next one is CPU request IO programming detail. CPU request IO operation, IO then IO module perform operation, IO module set status bytes, CPU check status bytes periodically. IO module does not inform CPU directly. IO module does not interrupt CPU. CPU may wait or come back later. The next one is CPU issue address. Identify module and device if If one is greater than per module, a CPU issue command, control telling module what to do. For example, spin up disk, test, check status, for example, power, and then error. Read, write, module transfer data via a buffer from two device. That is a command of enter operation. Okay, next one is input output, sorry, input output devices, addressing input output devices. Under program, input output data transfer is very like memory access CPU viewpoint. Each device can unique identifier, CPU commands content and identify address. Next one is our comes CPU waiting, no repeated CPU checking of device IO module interrupt when ready. Next one is interrupt driven input output basic operation. CPU issue read command, input output module get data from peripheral while CPU does not work. Input output module interrupt CPU request data and input output module transfer data. Next one is simple inter-processing. This processing is two types, hardware and software. Number one, hardware. Device control or other system hardware issue and interrupt process finish execution of current instruction. Process or signal acknowledgement of interrupt. Process push PSVV and PC on to control stack. Process load new PC value based on interrupt. This is a hardware system. And software save reminder of process state information, process interrupt, restore process state information, restore all PSW and PC. Next one is CPU viewpoint. Issue read command, do other work, check for interrupt at end of each instruction on cycle. If interrupted, save contents, registration process interrupt, fetch data, store. And next one is we have keyboard display interface to A2C55A. There is a diagram which we including in input and output devices. You can see in our screen, and there is a slide number 20. Next one is interrupt driven and program input output require active CPU. Intervention transfer rate is limit, CPU is tied up, DMA is the answer. Direct memory access. Next one is DMA function, additional module, hardware on bus, DMA control taken over from CPU for input output. Next one is typical DMA module diagram. If you can see data count, data register, address register, and control logic. There is a diagram which can data lines, address lines, DMA request, DMA acknowledgement, acknowledge, interrupt, read and write. Both data lines and data registration is connected each other, and they can do typical work in same time. Next one is DMA operation. CPU tells DMA controller read write device address, starting address of memory block for data, amount of data to be transferred. CPU carries on with other work. DMA controller deal with transfer. DMA control send interrupt when finished. Next one is DMA transfer cycle stealing. DMA control takes our bus for a cycle, transfer of one word of data, not an interrupt. CPU does not switch context. CPU suspend just before it accesses bus. For example, before an operand or data fetch or a data write slows down CPU, but not as much as CPU doing transfer. And then DMA configuration, the processor, DMA, input output, and then memory. Single bus DH DMA control. Each transfer uses bus twist, input output to DMA, then DMA to memory. CPU uses suspending twice. Then DMA configuration number 2. There is a process, then DMA and input, then input and DMA, and then